Okay, so last set of questions here, solving exponents. I do notice these were the tougher questions that were given, so that's a nice thing to see. The big key, of course, is the fact that we have a negative exponent, and we sort of have to recognize what that means. So if I'm doing this question, I have a couple of options here to get started, but the first thing I see is that I have regular numeric values here and here. I think I just like to get rid of that positive 1, get to the point where I have some value equal something and kind of work from there. So question A, I'm going to subtract 1 from both sides of the equation, and I will end up with 5x to the negative 3. This is 0, and over here equals 7. And now again, at this point I have a couple of options, I suppose. I could divide through by 5, isolate the x values. I have x to the negative 3 equals, dividing this side by 5 allows me to, maybe I'll write this one down, sorry. Okay, so divide both sides by 5, and of course what will happen on the left side is 5 divided by 5, and on the right side I'll end up with 7/5. Now, x to the negative 3, of course, is sort of where the problem occurs. I don't know necessarily how to, or I can't necessarily punch that into a calculator to sort of solve this question. But we know from before that the negative exponent actually means that we're going to flip the base. And so instead of x to the negative 3, if we deal with the negative, we can flip our base and get 1 over x cubed. Okay, so that's what the negative sign says. It basically says flip this base, so I have 1 over x, and maybe it's slightly better to write it this way. I'm flipping the entire base, so 1 over x to the exponent 3 will be 7/5. Now this is 1 to the exponent 3 over x to the exponent 3, and so writing it this way now is probably a little safer. Now, of course, what I'm looking to do is get x isolated so that I can actually have a final line of x equals some number. Clearly right now I don't have x isolated because I have a 1 divided by and then my term with x in the denominator. And so in the same way that up here I divided both sides by 5 to eliminate the x, I can multiply both sides here by x cubed, and the x cubes will divide out on the one side and be left only on the other side and in the numerator. Okay, so I'm going to take the 1 over x cubed and again I'm going to multiply both sides by that same x cubed. And anytime we multiply by something that doesn't look like a fraction, something without a written without a written denominator, we understand that that term has a denominator of 1. So again, the reason I chose the x cubed was because I know that I'm going to get x cubed times 1 divided by 1 divided by x cubed. So x cubed and x cubed will divide out. And of course, all I'm left with now over here is the number 1. Over here, I'm going to be left with 7 times x cubed divided by 5. Now, I still really want the x cubed to be alone, and so the same process I just went through here and the same process I went through up here, I can go through at this point. So I'm going to multiply both sides by 5. When I do that, the 5s will divide out on the one side, and I'll be left with just 5 on the other side. And then divide both sides by 7, and I end up with 5/7 is equal to x cubed. Now that's not quite my final answer, but that's really what I was trying to get to here. Once I know this, if I think about something like x cubed, if it equaled a nice number like 27, I would pick up my calculator, press the cube root button, and I'd find that x is the cube root of 27, which is the number 3. So same thing over here now. I'm going to, let me see if I have one here. I'm going to take the cube root of 5/7. Now on my calculator, I'm going to do bracket 5 divided by 7, close the bracket, and then the cube root is right here. And, oh, that is my final answer. So x will be approximately 0.8939. Okay. Now that seemed like a long process to go through. Depending on how comfortable we are rearranging things and with some of the math, we could probably do it a little bit quicker. And so this one I will do a slightly different way. Now, again, sort of looking at this, I think probably dealing with this -3 first is a good idea. So I'm going to add the 3 to both sides. Add 3 here, of course I get 0. 15 plus 3 is 18 over there. At this point, it might be a nice time to deal with the negative exponent. And so in the same way, x to a -2 is the same as 1 over x squared, or in this case, because there's a 4 out front, 4 over x squared. And now, basically, the denominator here, I want to multiply both sides by that value. So I'm going to multiply by the x squared, multiply by the x squared, and again, the x squareds divide out on the one side. So I've got 4 equals 18x squared. Divide through by the 18, 4/18 is equal to x squared. And then x will be the square root of 4/18. Now the interesting thing here, maybe a little bit more interesting than the previous question, when we do square root, if I take something like square root of 36, my natural instinct is to sort of think that that value is +6. And if it was written this way to start, that would be fine. But if I gave you this question and said, what are the possible values of x that would give me x squared equal to 36? When we take the square root, we have to consider both the positive and negative square roots. Because square root allows us, sort of the square root of 36, sorry, -6 times -6 is 36. So when we're dealing with square roots, we do have to consider both positives and negatives. And so over here, because I put in the square root symbol, I need to consider the positive and negative. If the original question showed me the square root symbol without positive and negatives, then I don't have to worry about it. But when I include it, I have to include both. Okay, so once we recognize that we've got plus or minus and the square root, we'll do the 4 divided by 18, 0.22222, and we need to take the square root of that, and the square root symbol's over here. And so I'm going to get positive or negative 0.4714. Again, approximately. X is approximately 0.4714, or x is approximately -0.4714.